Good morning friends. Today we are going to study how to find out the Norton's equivalent circuit across two terminals. In the previous lecture we studied how to find out the Thevenin equivalent for the same circuit. So let's start. So we have a battery voltage E or battery source E. We have two resistors R1, R2 and these are the points A and B. And the expectation is we need to find out Norton's equivalent circuit across point A and B. So what is the first step? So we have to put short circuit across point A and B. So if we put short circuit across point A and B, R2 goes away because when these two are in parallel, so we know in parallel resistance is the less as compared to the two resistances. So this R2 goes away straight away and this becomes short circuit, because if you short this, current is going to go through the less resistance path, basically zero resistance path, and this R2 doesn't have any meaning. That's why we are removing R2. If you don't understand, I will tell you one more time. We are going to short this, right? Whenever you are shorting points A and B, there is no resistance or zero resistance. That means infinite current will go from here. There will be zero current flowing through R2, so we have to disregard R2 or we have to remove R2. So once we get this circuit, right, once we short A and B, we have to find out the short circuit current flowing through point A and B. So ISC will become E upon R1. So that is the value of ISC. Value is voltage source divided by R1. What is second step? In the second step, what we have to do is, let's say in this circuit we have voltage source, right? So we have to short circuit this voltage source. And that's what I have done here, and remove the voltage source E and replace it with the short circuit. So once you short circuit this, R1 and R2 will become in parallel. You can see these are the 2 points, right? R1 and R2, they are in parallel. You can write or draw this R1 here also. So by that logic, R1 will become in parallel with R2, and we have to find out the equivalent resistance while seeing from this side across point A and B. And we have done this step in the previous lecture also. While finding Thevenin equivalent, value will remain the same. R1 parallel R2 is equal to R1 R2 upon R1 plus R2. So how to draw a Norton's equivalent? So we have to remember here, Norton's equivalent will always consist of a current source and a resistance, right? So what is current source? The value we have already found out, which is this, the short circuit current, which is E upon R1. So that's why E upon R1. And resistance, we know internal resistance, which is R1 upon R2. R1 into R2 divided by R1 plus R2. So friends, this is, so for this circuit, we have this as a Norton's equivalent. What was there in Thevenin's equivalent? Thevenin's equivalent, we had voltage source in series with the internal resistance. Here we have a current source in parallel with the internal resistance. I will show you. In Thevenin's equivalent, we had a voltage source in series with the internal resistance. In Norton's equivalent, we have current source in parallel with the internal resistance. That's what the main difference is. So I hope you understood Norton's equivalent, how to find out Norton's equivalent for a given circuit across point A and B. So I'm going to close this lecture here. Please let me know if you have any questions in the comment section. I will try to answer there. Thank you and have a great day.